Hi students, it's Mr. Hajgassim here, and today we're going to learn how to draw distance time graphs and also analyze them as well. Now, as a recap of something that you may have done before, we need to be able to do calculations involving distance, speed, and time. So it's important to be able to recall our distance, speed, time triangles. So distance goes on the top and speed and time on the bottom. And usually if we want to work out any one of these, so say if we wanted to work out distance, well, that would simply be speed multiplied by time. If, however, we wanted to work out time, that would be distance divided by speed. And if we wanted to work out speed, that would be distance divided by time. So very important to be able to recall these triangles to be able to do problems involving distance time graphs. Now, let's start with this question here. So what it says, well, let's try and just move this over here. There we go. So it says, how far did the car travel in the first 2 seconds? Well, first, this is our distance time graph. And we want to work out how far the car traveled in the first 2 seconds. So what we need to do here is draw a line at 2 seconds. So if I just annotate this, so after 2 seconds, we have time on the x-axis. So after 2 seconds, we traveled, or the car traveled, 40 meters. So the answer here would be 40 meters. And a very important point about distance time graphs, the distance is always on the y-axis and the time is always on the x-axis. So after 2 seconds, the car traveled 40 meters. Now it says, how long was the car stationary for? So the part of the graph that was stationary, well, that's going to be between, and if I use a different color, 4 seconds and 6 seconds, because as time passes, the distance doesn't change. So that means the car was stationary between 4 to 6 seconds. So how long was the car stationary for? Well, that's going to be 2 seconds. So we can write 2 seconds over here. So as time passes, the distance does not change. Now it says, what was the car's greatest speed? So in other words, how much distance did we cover in the shortest amount of time, or the most amount of distance covered in the shortest amount of time? Now, if I just erase these annotations, now let's think about this. Let's think about along this line here. So in 4 seconds, we cover 80 meters, or in 4 seconds, the car covers 80 meters. Whereas over here in 2 seconds, so if I pick, say, from this point to this point, in 2 seconds, the car covers, we're starting at 80 and it reaches 200. So in 2 seconds, the distance covered, or the distance traveled, is going to be 120 meters. Whereas over here, if I use a different color, from here to here in 4 seconds, so in 4 seconds, only 80 meters was covered. So that means per second, for every second, the car traveled only 20 meters. Whereas here, every 1 second, the car traveled 60 meters. And that makes sense, because if we think about our distance, so distance, speed, and time. So if we want to work out our speed, well, speed is equal to distance over time. So in this case, the distance traveled is going to be 80 meters. And the time taken, well, that's 4 seconds. So our speed was 20 meters per second along this line. Whereas over here, what we would get is, again, distance over time. So the distance is 120 meters over 2 seconds. But that gives us 60 meters per second. So along this line was the car's greatest speed. And notice here, along this line, along a straight line, speed's always constant. So even if I was to pick two different points, the speed along this line will still be 60 meters per second. So if I rub this out, and if I was to pick, say, from this point to this point, now here, in 1 second, we cover 20, 40, 60 meters. So over here, our speed is still 60 meters per second. Likewise here, if I was to pick two different points along this line, and if I use a different color again, so if I was to start, say, from here to here, as we travel 1 second, we cover 20 meters. So again, the speed from this point to this point is 20 meters every second. So along a straight line, speed is constant. And an easier way, without having to do all of these calculations, an easier way to determine where the car's greatest speed is to look at the steepness of the line. The steeper the line, the greater the speed. So in this case, we would actually have to calculate the greatest speed. So the greatest speed is 60 meters per second. However, we should know that this line here is where the greatest speed of the car is, because this is the line that is the steepest. And if we had another line, which was even, say, something like this, for instance, well, that is very steep. It means in 1 second, you're covering 20, 40, 60, 80, 100, 120, 140. So the steeper the line, the greater the speed. All right. So let's move on. And if I clear the annotations here, and we can go on to the next question. So it says here, a train travels from Tridigo to Bangor. The train leaves at 9:15 and stops at New Chapel along the way. The distance time graph below shows the train's journey. Now, what is the distance between Tridigo and New Chapel? Well, where is New Chapel? How do we know where New Chapel is? Well, it says here, the train leaves at 9:15 and stops at New Chapel along the way. So this is where our train stops, because it's stationary along this straight line. So the distance, well, that's going to be up to here is 100, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 50 divided into 10 parts, that means each part is going to be 5. So that's going to be 105. So this is 110 over here. So each line is 5. Therefore, we have 2 lines. So that's going to be 110 meters. Or I should say miles in this example. So what is the distance between Tridigo and New Chapel? Well, that's from here to here where the train stops. So that's 110 miles. Next question, it says, how long did the train stay at New Chapel? Well, the train was stationary during this time interval. So that's going to be between, now again, I need to know what each line, how many minutes each line is. So that's 10 o'clock, 1, 2, 3, 4. So 1 hour is split into 4 lines. So each line is going to be 60 minutes is 1 hour. So 60 minutes split into 4 parts. That's going to be 15 minutes at each interval. So this is going to be 15, 30, 45, and then we get to 11. So from 10:30 till 11, it was stationary. So that means the train was stationary, or the train stayed at New Chapel for 30 minutes. So from here to here, or we can just count. So from here to here, that's 15 minutes. And from here to here, that's another 15 minutes. All right. And let's move on to the next question. What speed did the train travel between New Chapel and Bangor? So what speed did the train travel between New Chapel and Bangor? So the speed. And again, speed is equal to, so if I just draw my distance time graph, distance speed time triangle. So what speed did the train travel between New Chapel and Bangor? So from New Chapel to Bangor, we need to work this out. Well, the time is going to be, how long did it take? It took, that's 15, 30, 45. So that's 45 minutes. And then the distance traveled is going to be, so we are going from 110 miles to 200. So that's going to be 90 miles. Now, generally, speed is calculated per hour. So we need to convert 45 minutes as a decimal in terms of hours. So 45 minutes is 3/4 of an hour. So 3/4 of an hour would be 0.75. So we want to work out the speed. So speed is equal to distance divided by time. So that's going to be 90 divided by 0.75. And that will give us, if I use my calculator, 90 divided by 0.75, that will give us 120 miles per hour. If you were to work it out in terms of minutes, well, what we would have to do is 90 divided by 45, and that's going to be 2 miles per minute. So you could have also worked out the speed in terms of minutes, but generally we work speed in terms of hours, unless this question specifies otherwise. All right, and then the next question. So it says, how far did the train travel in total? How far did the train travel in total? So again, we're starting, well, in total, actually, we're starting at 0, and then that's going to be up to 200 miles. So the total distance traveled is 200 miles, because that's where the journey ends. And then lastly, the question says, what was the train's average speed for the entire journey? So what was the train's average speed for the entire journey? So what we need to do here, if I just rub some of this out. Again, what we need to know is the total distance covered. Well, the total distance covered is 200 divided by the time taken. So we're starting our journey at 9:15, and we finish our journey at 11:45. So that is 2 hours and 30 minutes. So the time is 2 hours 30. Now I'm going to convert that into a decimal. So 2 hours 30 would be 2.5 hours. So the train's average speed is going to be 200 divided by 2.5, which will give us 80 miles per hour. And that is our answer. So the train's average speed for the entire journey is 80 miles per hour. All right. And let's move on to another example. So now here it says Birmingham is 120 miles from London. Dawn arrived in Birmingham at 1400. Complete the graph. So here, this is where we need to draw the graph, and or in this case, complete the graph. Now, Birmingham is 120 miles from London, so this is where the journey would have ended. However, Dawn got to Birmingham at 1400, so 1400 is over here. So what we need to do is make a point, 1400 and 120 miles. So we just need to draw a straight line joining to the point that we've just plotted on the graph. And it's simple as that with a question like this. However, it gets a little bit more complicated. So again, here it says, if I just move the animations, it's best if I put this here. So the question says, Ali cycled from his home to his friend's house. He stayed at his friend's house and then traveled home. At what time did Ali leave home? Well, he left home at this time here. That's halfway between 9 o'clock and 9:10. So he left home at 9:05. And the next question, it says, how far was Ali from home while visiting his friend? This should be, not her, it should be his friend. Well, Ali must have arrived at his friend's house at this point here. And this point is 8 kilometers. We need to label the distance time graph. So this is going to be distance on the y-axis and time on the x-axis. And this is the point where Ali must have arrived at his friend's house and he stayed there for some time. So when he arrived at his friend's house, he was 8 kilometers away from his house. So that's going to be 8 kilometers. Now, the next question, how long did Ali stay at his friend's house? Well, he stayed from this point to this point. So that's going to be, how long is that then? So got to his friend at 9:20. And then he was there until this point here. So that's going to be 9:30, 9:35. So he was only there for 15 minutes. And then the next question, it says, Ali arrived home at 9:55, traveling at a steady speed. So if he's traveling at a steady speed, we need to draw a straight line, because remember in the first slide we said a straight line indicates constant or steady speed. So it says complete the distance time graph. So if Ali arrived back home at 9:55, we need to make a point at 9:55. So that's 9:50. So at 9:55 is a point when he would have arrived back. So we need to draw a line from here all the way to here. So this is what our line would look like, and I will use a different color. And we just need to join these 2 points up. And along this line, the speed is steady. So we've now completed the distance time graph. All right. Now let's do this question here. So this is where we have to actually draw the distance time graph rather than complete it. So it says, below is a breakdown of Kevin's journey to work. He left his house and walked at a constant pace for 20 minutes until he reached a bus stop, which was 1 kilometer from his house. So he left his house and walked at a constant speed for 20 minutes. So if I make some points here, so he walked for 20 minutes until he reached the bus stop, which was 1 kilometer from his house. So in 20 minutes, he walked 1 kilometer. So if I just draw my line here, and maybe I can do that again, starting at 0. Here we are. So he walked at a steady speed for 20 minutes and he covered 1 kilometers. So distance traveled, and I can write in kilometers. And then it says He waited at the bus stop for 5 minutes. So for 5 minutes, he was stationary because he wasn't moving, he wasn't covering any distance. He was stationary for 5 minutes. So from 20 to 5, we just need to draw a straight line here. And then he got on the bus, which drove 5 kilometers for 25 minutes at a constant speed. So again, for 25 minutes, so that's going to be 5, 10, 15, 20, 25, and it drove 5 kilometers. So that's going to be 1 kilometer, 2, 3, 4, 5. So this is where we are now going to end up. So we need to draw a line from here to here. And this is our next point. So again, we can see for 25 minutes, we've covered 5 kilometers, or in 25 minutes, we've covered 5 kilometers. Therefore, so far, his total journey has taken 6 kilometers. And then lastly, it says he got off the bus 1 kilometer from his workplace. So he still needs to travel another kilometer because he's 1 kilometer away from his workplace, and jogged at a constant speed for 10 minutes until he reached his place of work. Now, again, these are all key words here. Constant speed. So when it says constant speed, we know we just have to draw straight lines because along a straight line, speed is constant. So he needs to travel 1 more kilometer. So he's going to end up somewhere along here. And he jogged for 10 minutes. So it took him 10 minutes to reach his place of work. So we need to go 5, 10 minutes here, and then another kilometer up here. So this is the line which we need to make, or that's the point which we need to make. And then we can draw a line to that point as well. So what we can see here is, in total, he has traveled 7 kilometers and his journey took 60 minutes as well. So this is how we can put this information onto a distance time graph, I should say. So initially he walked 1 kilometer, then he was stationary at the bus stop, then he traveled another 5 kilometers, and then finally he had 1 more kilometer to do, which he completed in 10 minutes. All right, so let's move on to the next question. Now, this is an exam style question, and I think this should be a really good one to complete. So if I just clear all the drawings, all right. So it says here, Lily goes on a car journey. For the first 30 minutes, her average speed is 40 miles per hour. So right now in this question, we have time. So time is equal to 30 minutes or 0.5 hours. And we also have this speed, which is 40 miles per hour. So what I know is that in the first 30 minutes, she was traveling at 40 miles per hour. But to be able to draw my distance time graph, I need to be able to work out what the distance is. And this is where your distance speed triangle comes handy. So distance, speed, time. It doesn't matter which way around you put speed and time. However, distance is always on the top. So we know distance is speed multiplied by time. As we have our speed in hours, I'm going to use hours for my time as well. So my distance is going to be speed multiplied by time. Therefore, that's going to be 0.5 hours, which is my time, multiplied by the speed, which is 40, giving us a total distance of 20 miles. Therefore, in the first 30 minutes, Lily would have traveled 20 miles. So this is our first point that we need to plot. and then we join a line over here. And that would make sense, because if the speed is 40 miles per hour, that means in half an hour she should cover 20 miles. And that's exactly what we have here. In half an hour, she's covered 20 miles. And then it says she stops for 15 minutes. So again, we need to draw a stationary line here. So that's 5, 10, 15 minutes over here. And then it says she then completes a journey at an average speed of 60 miles per hour. The total journey time is 1 hour. So that means she's traveled only another 15 minutes, because her journey should finish at 60 minutes. However, again, we don't know how much distance she's covered. So once again, if I erase all of this, we need to work out the total distance covered. So what we do know is that the total journey time is 1 hour. So there's only 15 more minutes of a journey to go. So the remaining time is equal to 15 minutes, which is equal to 0.25 hours. Remember, 15 minutes is 1/4 of an hour. So that's going to be 0.25 hours. And her speed is equal to 60 miles per hour. Again, we want to work out the distance. So that's going to be speed multiplied by time. So that's going to be 60 multiplied by 0.25. And what would that give us? So that's going to give us 15 miles for her distance. So 60 times 0.5 gives us 15 miles. So she travels 15 miles in the next 15 minutes. So that's going to be 5, 10, 15 miles. And then we just need to draw a line over here. And that's our distance time graph complete. So again, we had to do some calculations with regards to distance, speed, and time. So you need to be very good with these, especially when you're completing and drawing distance time graphs. All right, boys and girls, I hope you found this useful, and I hope you have a nice day. Thank you, and bye.